Hello. Hi, Juri. Hi, Helia, Minna, Omar, Saif,
Hello,
Aman
Rana.
Allah. Hi, everybody here also.
Huh?
Okay, we will continue chapter of electrolysis. Well, at the beginning, I said this chapter it's a little bit hard, so we have to understand. It is not memorizing at all. All right. So we will go through this chapter quickly about what we said last time, and I will finalize this chapter today, inshallah. After that, I will send the homework about electrolysis from last exam, from June 22, and other papers, so we will practice together, inshallah, next class. All right? Let's start to talk about the meaning of electrolysis. Please pay attention. Electrolysis, that means we have movement of electrons. We have electrons here in this process. All right? Mainly, if you need to draw a diagram of electrolysis apparatus, electrolysis, it is made of what? Mainly we start with this battery or dry cell. Let's see this again. It's so simple. This is a dry battery or dry cell. All right? It is called cell. Wrongly we say it is battery. All right? In this side, which it has something here from outside, it is the positive end. It is the positive end. This positive end, it's called the anode area. It's called the anode. And this side with nothing, which is flat, it's called negative. You can see sign on this dry cell. You can see it easily if you check any battery at home. All right? So, but our name in this chapter, it is dry cell. A battery only available in the car. But you can say it is battery, acceptable. But if they ask a labeling of these two ends, this sign, big sign, it is anode, and this side, which is negative, it's cathode. All right? Why we use this one? Source of energy. It is electricity. If you put in remote, you can switch on or off any device. So this battery, it has chemicals. Well, chemicals give me energy. So I need this energy to do what? To break ionic compound. That is the meaning of electrolysis. All right? Let's start to draw. Simple drawing. Always a negative terminal or a cathode, we draw it very small sign. All right? We wire. We may fix a small lamp or light bulb. All right? So this negative terminal is called the what? Cathode. You have to memorize that. Cathode. And the bigger sign, I showed the dry cell. This positive, it's called anode area, which is positive. Then connected here with two rods. Two rods, L'Oreal, it's called electrodes. Electrodes. All right? So if you draw, if they ask to draw, try to draw better than me, because the touch screen, it is hard. And I put all this in a beaker or any container. So what we have here, I have cathode and anode, wire, lamp, with two electrodes. Two electrodes, it should be good conductor of electricity. That's the most important property. Good conductor, because we will see movement of electrons now. All right? And it is inert. What's the meaning of inert يا أدهم? Inert. سرحان في إيه؟ ركز معايا. What's the meaning of inert? What's the meaning of unreactive? Say in your own way. If you put with other material, there is collision or never happen? Never happen, never react. Never react. Inert or unreactive, never interfere in the process. That's the meaning of inert. All right? We have this container, and we said also the other property is what? High melting point. Very good, you use it. Because sometimes we need to heat to melt the material. So I don't need my electrodes to melt. Three properties you have to know by heart. I repeat again. Good conductor of electricity, it is inert and high melting point. The most famous one, Yamina, we use as electrodes. What's the material we use usually? Minna. Minna? Okay, Salma, say.
Another mineral.
Platinum or titanium. Very good. Thank you, Minna. Graphite or carbon. That is the most famous one. But if they ask you in the exam to write down metal, only you have two metals, platinum or titanium only, because they are unreactive. They never react. This is important. And we talked here about our electrolyte. We talked just last time about electrolyte. It is what? It is either molten or aqueous. Why? It should be molten. The definition, to remember it again, it is electrical energy is used to break ionic compound, molten or aqueous. Yalla habibi. Excellent. So I need the ions to move. Excellent, ya Jumana. Yes, I need free ions. But if we have our table salt, for example, it is solid state. We understand the movement of solid, it's what? Just vibration. Very good, ya Angie. So I need to melt it. What's the meaning of melt it? Just heat it. We need to break a bond. We get positive ion and negative ion. Or aqueous. What's the meaning of aqueous? We dissolve it in water. The meaning of aqueous, only the material we dissolve, we use it to dissolve it in water. So it is water. So we get ions are free to move. It is important question. Sometimes they give you an electrolyte in solid state, and they give you a question, why a lamp is not lighted? Why the electrolysis is not going on? What's the answer? Yalla Habib. Because it is solid state. Yes, that is the right answer. Thank you, Safe. So if we have solid state, ions are not free. Exactly like we studied in state of matter. A solid can't move. Think always about your desk. A desk can't move unless you move it. All right? But it can't move like water, like gas. That's never happened. So if you get any electrolyte, they write down, for example, lead bromide, solid state. And they said, why a lamp not lighting up? Why electrolysis never go ahead? Simply because the material is a solid state, while ions are fixed in its place. That is a model answer. We will do all these questions together, inshallah. So a definition, it is what again? We breaking down ionic compound. That means we will not do electrolysis for covalent. No, we will do it, but that is the right definition. So electrical energy break ionic compound, and when we use energy, it is exo or endo. If you supply energy, it is endothermic process, because today we'll talk about galvanic cell or voltaic cell. It is exothermic. We will compare. All right, we'll start talk about molten sodium chloride. It is so simple to write down the equation, half ionic equation. Please study. You will confirm this data by solving past paper, but study please. I have Na plus and Cl minus. I'm talking about molten material. Molten, that means I don't have other ions, only a salt. Okay, we understand that an opposite charged particle attract. So where is sodium ion will go, ya Fatima? Fatma Ahmed. Where is sodium ion will go? To the cathode, exactly, to the other terminal, which is the opposite side. Okay, so if they ask a drawing, please draw particle in the electrolyte itself. All right, so this I can show by an arrow going toward this one, and the chloride ion, of course, will go toward the anode. Let's write down in half ionic equation. At cathode area, I have Na plus. How many electrons? 1. What do we get? Sodium. What is the observation of sodium? Gray metal. Very good. So if they ask about an observation, something either doubles or even color certain color of bubbles, or gray metal. So we get gray metal. Just a second, ya Adam, I get back to you, Habib. So we get this observation if they ask about an observation. What kind of reaction here? Omar has there. What kind of reaction? Oxidation or reduction? Omar.
Oxidation.
Yes, miss.
What is this reaction called? Oxidation or reduction? And explain.
Miss, it's oxidation because it's
Omar,
losing
Omar, pay attention, Habib. A sodium ion gained the electron, so it is what?
it is a reduction because it gained.
Yes, reduction. Very good. Because it gained electron or oxidation number decreased.
Decrease.
Very good. That's it. It's a question. So they will ask about the redox with testing. A testing of gas. Your question, Adam, it's what?
As soon as I asked Miss Madam about this, why she put the electrolytes on the other side, she told me, I told her, is it okay to put it on this side?
It's not for positive. She is talking about a negative. Just wait. I know your question now. I have this Cl minus at anode, my way, and you will get a full mark, right? With all respect to Miss Romano. Okay? Negative 1 electron, I get Cl. But the halogen is what? Diatomic. 2. You never put the value under the ion. Where I write? In front with 2 electrons. Here I have Adam said, Miss said electron, it should be in this side. You can check in mark scheme. I said either you write it down like this, acceptable by either syllabus. I get chlorine plus 2 electrons here. They will ask to test chlorine. So if she said no, you have to put an electron on the right hand side, do it for her. But in the final exam, acceptable. You have the mark scheme. You can show that to your teachers. I can send any mark scheme for whatever pick. All right, I have it on the site of the teacher. All right. So equation at cathode and equation at anode. In testing of chlorine, we use what? Damp litmus paper. Especially gases. الجازس الكلورين, especially chlorine and the ammonia later on when we do analytical, it should be damp. Alright? So we get what? It is bleached. Bleached يعني we get white color. I will do another material. For example, aluminium oxide, molten aluminium oxide. So Al positive 3 will oxygen negative 2. يلا يا ندى, I need to write down the equation at cathode. Al positive 3. We said plus plus. How many electrons? 3. Very good. What do we get? Aluminium. Only aluminium because plus 3 and the negative 3, 0. We write down the product. It is neutral. We never have a product as ion. Ion, it is not a product. All right? Now, if I need to write down the equation at anode, I have O negative 2. Yalla, who will answer? Yalla, ya mister. Negative 2E, we get O, monoatomic, never to be that. So 2. And then I get 2 particles from that. And 2 times 2, 4 electron. That's it. You want ya Adam to write down the electron on the right hand side? No problem. Write down that for your teacher only. Right? That is the equation. Either this one or this one. I said here in negative just to remember that in the exam, because in the exam always everybody has stress. So you never forget that. So plus plus minus minus. Alright? Any difficulty in this part? Alright. Let's remember we talked also last time about aqueous solution. We start talk about electrochemistry series. Please pay attention. Important question. I'm talking about concentrated sodium chloride. The meaning of concentrated, too much salt, too much from this material. Concentrate, as you put a lot of sugar in cup, so you get it too sweet. Concentrated. That means I have this particle, I have, of course, a water molecule. Well, that is the best way also to do it in the exam. You never do a mistake. Now we have 4 particles compete with each other. I have 2 positive particles and I have 2 negative particles. What I do? I will write down also dilute. What's the meaning of dilute? You add a lot of water. So I write down always in 4 particles, all right? I have H or OH over here. In this case, this material, it is the winner, all right? And in either case, if we go to the discharge series or electrochemistry series, I said memorize what we have under a hydrogen ion. Anyone remember? Copper, very good, ya Muhammad. And silver ion only. Whatever other material on the top. If we have potassium, yes, it is on the top. If we have magnesium on the top. If we have aluminium on the top. If we have zinc ion on the top. Alright? Just memorize what we have under a hydrogen. What we said about that? As you go down this electrochemistry series, it is easy to form at cathode area. So, competition now between a hydrogen ion and sodium ion. Which particle will go? Yeah, let's say hydrogen ion always will never ever get sodium. Never. From a solution, either concentrated or dilute. Never write down this equation. Important. Alright? So I write down an equation for both. I have, write down here, H plus E will get hydrogen. Will always diatomic. So 2, 2, and 2. I think all of you familiar about writing this equation. Yes or no? Anyone has difficulty to write down this equation? Omar, it's okay, Habibi? The kind of reaction is what? Reduction.
Yes, I don't understand this part.
Or an oxidation number decreased. A testing of hydrogen. Lighted split, burn with pop sound. Alright? We will see all this question when we practice question from our past paper. We have also, so at cathode area, in both cases, we get hydrogen bubbles. It is colorless gas, has no color. If they ask observation. Alright? Then, we have 2 series you have to know. We said and concentrate, that means we have too much salt. So a chloride in the bottom will OH on the top. That is what you need to know only. Even I write down in the note or any chemistry book, you see a lot of ions. That's what you need only in this kind of question. Alright? In case of concentrate, you have OH on the top. So competition also going toward an anode, a chloride ion will go first. In case of dilute, I have too much water. So, too much water. So this particle, it will be in the bottom. Once you memorize that, it is done. So this particle, it will be the winner in the case of dilute. Well, I gave you one clue now to remember how to do this question in few seconds. Okay, so in both cases, we get bubbles of hydrogen gas, bubbles of colorless gas. Alright, in both cases. Now, competition between a chloride and the hydroxide and the concentrate, we get what? Chlorine, very good. So at anode area, so Cl minus E, we get Cl with diatomic, where you can write down also electron on the right hand side. What is the color of chlorine? Who remember? Green, very good. Green bubbles at anode. So we get, yes, it's this OH here, yesal. In OH, I have concentrated salt. The meaning of concentrate, for example, I have this cup of water. I am adding a lot of salt, a lot of NaCl. So this particle, it will be in the bottom of electrochemistry series of the negative ion. From where we get this particle, NaCl, I have a lot of salt in this case. Okay? I'm repeating, Ya Omar. I'm repeating. Pay attention, Habib. I have here in the note I give you electrochemistry series. Any particle above the hydrogen, group 1, 2, 3 ions, or 4 transition metal. You have to memorize what we have. We will talk about it today. Copper ion and silver ion. They said they found by the practical work in the lab, research work, they found the ion in the bottom, it go faster. All right? So if you have silver ion with copper ion in the same time, so silver ion will go. If you have copper ion and hydrogen ion, copper ion will go. If you have hydrogen ion, aluminum ion, hydrogen ion will go. So where exactly an ion in the bottom? All right? With same idea here. For concentrate, that means I have too much salt. So the particle in the bottom, this is faster to go toward the anode. Just memorize these two parts, these two series. It is written in the note. So you write down the equation at cathode. For both cases, we get hydrogen gas. We never get sodium. We never get metal from solution of sodium chloride or potassium bromide or whatever. We will repeat that with another salt now. All right? And then at anode, we get green bubbles if they ask an observation. Green bubbles at anode area if they ask an observation. Well, this is the equation. All right? What we get here? Which particle in the bottom? An OH ion. What's this OH ion for? Oxygen gas. Oxygen gas. Well, I will give you a clue here about this part to remember in the exam. I will take 4 parts. 4 parts. 4. All right? Just to balance. This, I will subtract how many electrons now? 4. Minus 4 electrons, we get oxygen gas plus 2 water molecules. If you want to write down the electron also in this side, up to you. All right? So instead of getting green gas, we get colorless gas. That is different case in case of diluted one. All right? So simply, if you get dilute salt, sodium chloride or any dilute, exactly as you do electrolysis of water, if you break in water, what we get? Hydrogen and oxygen. That's it. It will help you to remember. All right? In case they write down in the question dilute, all right? That means we are doing electrolysis for water. We get hydrogen and we get oxygen. All right? If they didn't write anything, either dilute or concentrate, they write down solution on. So we assume it is concentrated one. Clear? We will practice together the question because this part important again, I repeat. You will get it inshallah in your final exam. Just second, Yejwan, I get back to you. So we get here hydrogen gas and we get chlorine gas. What is the remaining here? Very good. Sodium ion combined with OH ion forming what? Alkaline sodium hydroxide. So from the concentrate, we get hydrogen gas, with chlorine gas, and sodium hydroxide. To memorize this one, at cathode area. At cathode area. All right? Let's get back little dilute. We said we get hydrogen and oxygen. Exactly as you have water and you break it into its parts. And what will happen to the salt? Remain nothing. We never get sodium or chlorine. All right? We get 3 material. We never get metal from this solution. I repeat again, important question. All right, Shabab? You get that? I repeat again. If you get concentrated or dilute, I wrote it here in the note. I wrote everything here in the note. For dilute and concentrated in page 6 in the note. Okay? Diluted sodium chloride and concentrate. I write down this sign for you again. Once you this sign, you see this one, Bi'Iznillah, it's the question in your final exam. Alright? In case of dilute, LOH, it is a winner. You see, ease to discharge. What's the meaning discharge? It loses its charge. All right? Dilute, I have too much water. Water, so we get OH from the water.
Okay.
If you break the water, it is H and OH. So this part from the
Okay.
water. Concentrated, it is another story. I have a lot of this material, NaCl. So if you break NaCl, this it is the winner in this case. Well, it is good idea to write down 4 particles this way. So competition between the sodium and
Lowers the
hydrogen.
dose.
In either case, we never get sodium. Never. So, because hydrogen it is in the bottom here of this charge series. Yeah, Juman. You see, the hydrogen is over here. Where is sodium? You see this arrow? Easy to discharge, easy to form. Again, the ion in the bottom always go faster. You get it now? So we never ever get any of these ions in case of solution. Never. All right? So in both cases we get hydrogen. That was your question or another one? So we get hydrogen gas, colorless gas in both cases at anode, at cathode, sorry. Goes here negative, with that is a positive. We leave the sodium for a while, and then for a dilute, this particle, it will form oxygen gas. Again, you can write down this equation, Mr. Adam, this way. So we get oxygen plus 2 water molecule plus 4 electron. It is exactly same, all right? And chlorine, instead of LOH, you can write down this way. It's by chance, I wrote it here. But you can write down our own way always. 2Cl minus, minus 2 electron, and you will get a full mark, inshallah. So, if they ask a difference between the 2 cases, here we get green bubbles, and this one colorless bubbles. And in the case of dilute, what we get? The salt is remain. When you remove the water, becomes more concentrated, or just you write down sodium chloride. But in this case, what we get? Alkaline material. In fact, we use this technique in a large scale to prepare hydrogen, to produce chlorine. We use the chlorine later on to treat the water. If the water, it has bacteria, we use the chlorine to kill the bacteria or germ. Sodium hydroxide, also we will talk about it in organic, in manufacturing of soap. All right? We will see all that. So it is important question. Please study. Okay? You get it now, ya Omar? Omar has that? Everybody gets this part. Let's do another example similar. Whatever is soap. Let's see. I will do another example. Let's do another example. Alright? What I will do, dilute or concentrate. I need somebody to help me. If I'm talking about concentrated potassium bromide, what's the meaning of concentrate? This is a particle. Okay? H, always don't forget to break it. Right? Plus or plus, or minus, minus. We dilute. What's the meaning of dilute? LOH, it will be the winner. Alright? I have always this particle available. Let's do it. Once you understand, you can write down an equation and you can answer any question. That's another example here, ya Omar. Pay attention. So, always hydrogen ion will potassium ion on the top. As you go down, which particle will go first? Hydrogen ion or potassium ion? Hydrogen always. Okay, Omar? So, ion in the bottom, it is always going faster. So, at cathode area, so what we write down the equation, 2H plus 2 electrons, we get H2, colorless gas. Alright? Dilute, if I write down this series, that means this particle, yes, OH in the bottom. We didn't write the other product. So I have this OH and I have LBr minus. Well, regarding this one, concentrated, I get LBr minus in the bottom and OH in the top, because we said too much of this one. Alright? Too much, that means this coming from where? From salt. And why this in the bottom? Because I have this more. Major part available is coming from the wood. Same concept, a particle in the bottom, it will go first. Once you get that, so it is so easy. Here it is the same equation at the third area. I think all of you familiar. Now, I repeat this part again. Which particle will go now, bromide or hydroxide? Bromide, very good. Let's write down the equation. Br minus, I write down 2 minus 2 electron get bromine at anode area. In this case, bromide or hydroxide? Hydroxide, excellent. We memorize this equation. I know it's a little bit hard, but from the practicing, you will memorize it. 4OH minus 4 electrons, we get oxygen instead of bromine, plus 2 water molecules. All right? Now, let's see what is the leftover in this container. Let's see. El bromide ion gun. If you do this way, you never forget. Well, hydrogen ion gun. So what is the leftover? Potassium hydroxide. Excellent. Excellent. It's okay, Ya Omar, now. So potassium hydroxide where? At cathode area. Well, here I don't have explanation for your group or for your level, because this I have to teach you 3 more chapters. It is not in the set. Just memorize. Okay, what is the leftover now? If this gone and this gone, what we have? That's it, the salt itself. We will see salt. We add more water and we continue. That means this process, we continue to get what?
Salt.
Hydrogen and the oxygen only. If once you read this word dilute, exactly as you break the water into H2 and O2. I think now it is very simple for all of you. You have a question, like? This equation, yes? For the dilute. For dilute, it is in the bottom of bromide. We get back the note again, ya Layla, it's over here. Okay? Exactly chloride, we have after chloride bromide. What we have after? We have iodide. Right? So all this ion in the bottom of a hydroxide. In case of, here I have dilute, I have here chloride, all the halide will be here. So chloride, bromide, and the iodide. Alright? Okay, I repeat again this part. You have here, I just give another example. It is rare question in your exam. I'm talking about potassium bromide. Okay? El potassium ion group number 1, always in the top, while hydrogen in the bottom. We understand that the particle in the bottom will go first. So in both cases, we never ever get metal. What we get? We get hydrogen gas. We get hydrogen gas. Alright? Then, whenever this particle go, I'm talking about concentrated and then dilute. El dilute, we understand that's too much water. That means this particle always a winner. Whatever we have, chloride, bromide, iodide, it will be on the top. Alright? El concentrated, no, el concentrated, we have this from salt, too much. Alright? So we have el bromide, where even if you have iodide instead of potassium bromide, potassium iodide, so this one always in the bottom will OH in the top. This, it is concentrate, that means I have too much part from the salt itself. If you have dilute, that means too much water. I have a lot of OH. Alright? Simply you write down the equation now, ya Fatima. So the hydrogen in both cases formed at cathode area negative. The hydrogen positive, it will go toward the cathode. It is a question. A positive particle will go toward the cathode. All right? Now, for the concentrated, which one in the bottom? This particle. Write down an equation. So, 2 bromide ion, you remove an electron, so get bromine at anode L. What about this one? Dilute, this particle. It is a lot of water in the container. All right? What's this one for? Oxygen gas. Exactly as you break the water into its component, H2 and O2. All right? What is the left over here in this? Is salt itself remain. Is salt itself at the third probe. What about this one? Let's see. Okay? This hydrogen gun, bromide gun, so get alkaline solution. All right? I know it's a little bit complicated, but hopefully just go at, once you get home, if you have free time in the weekend, put a chapter in front of you and start. Write down the particle where this will go. And then, once we solve homework together, it will be familiar. LOH. I write down, I know it's a little bit hard equation. 4 particles. I will get 4 OH ion. Okay? Because I will form oxygen. I will get O2. I get SO2. Also, few water molecule also form. 2 water molecule form. Now to balance this equation, you see, how many hydrogen in this side? 4H. It is this one. How many oxygen? And the 2O. Well, here I have 2O. Yeah, I have 4O also. So 4O. That's why you memorize. I take 4OH ion and you remove 4 electrons. You may write down in this side or you subtract from this part. Up to you. You write down in one side only. Either by subtraction, we said this way you never forget. 4 OH ion minus 4 electron, we get oxygen plus 2. Okay? I know it is hard part. That's why I said let's do electrolysis. This واحنا still early in the year. أيوة لا. ال OH negative, where it will go? What is the name of the anode or cathode? What's the sign? Plus. What is the anode? It is anode, it is positive sign. The opposite charged particle attract each other. We will practice, don't worry. Don't worry. يعني just give a chance كده until we solve homework from our past paper. And then we do a quiz about electrolysis. That is the point. Joanna will kill everybody here in this room. It's fine. Okay, now let's see what other question you may see about this part, but we go further about a particle here in this electrochemistry series. What we have here under the hydrogen, important, copper ion and silver ion. So if we get copper ion and hydrogen ion, you add them, which particle will go toward the cathode? If you have copper ion and hydrogen ion in the same electrolysis, huh? Copper or hydrogen ion will go first. I have 2 positive particles here. Which one will go? Exactly, copper ion. In the bottom always. Just to check which location. So, in hydrogen, please memorize. It is just 3 parts. Hydrogen, Cu plus 2 and Ag plus 1. I don't need any other memorize for this series. We will see the question together. I'm talking now another more important than sodium chloride. What is this you miss? It is copper sulfate solution. Aqueous copper sulfate. Aqueous copper sulfate. So I have water here. Alright? H, OH. Alright? I have the same 4 particles compete with each other. I repeat, important. You will get it in your exam also, if they will ask about an electrolysis. Alright? We have 3 papers in chemistry, so A high probability for this chapter, yes. Now, let's write down the particle again. El positive. El hydrogen, what we said now. El hydrogen, copper ion in the bottom. Now, what Adham said, copper ion will go first toward cathode area. Positive will go toward the negative terminal, which is called cathodial layer, right? Negative term. Let's write down the equation. It's so simple. Cu plus 2 electrons will get Cu. What is the observation? What's a copper? Muhammad. You break your fasting, mashallah. Muhammad بيصوم الاثنين والخميس. I will not give food now. Yalla, what's the color of copper? Brown or rich brown. Thank you, Habib. A kind of reaction, it is reduction. A reason, an oxidation number decrease or gaining of electron. Right? We revise also. So appearance, how it looks like, what you observe, color, reddish brown or pink, only. All right? Now, so competition, we understand that the copper gun. Let's go to our series. If you see sulfate or nitrate, oh, I didn't record this class, yeah, no problem. Sulfate or nitrate, all right? What I have here, what we have else, I have OH ion. We forget this particle completely. They never form any material at anode L. They go, but they never form a proton. All right? Again, I repeat, if you get sulfate or nitrate or even carbonate, so this polyion, carbonate, sulfate, nitrate, they never ever form a product, but they may be attracted toward the anode. So always we get what? The equation of safe amine, 4OH ion. That's why I said you will memorize it. Minus 4 electrons. We get oxygen gas and 2 water. So we get copper, metal. Yes, we extracted the metal from solution now. We can extract the metal from a solution under hydrogen ion only. So LOH gun. Now, what this material will form? What we get Yamina from this both material? Juri or Minna or Saif Hassan. What we get from these two material if you add together? Sulfuric acid, excellent. We get H2SO4. H2SO4. Yusuf said hydrogen sulfate. It is good. At least they try. All right? But it is sulfuric acid. Get back to this question. Important question again. Thank you, Minna. It's right answer. So let's see again. Competition between the copper ion and hydrogen ion. Which one in the bottom? Copper ion. So we get copper metal. We need it to make a wire. Already we studied the extraction of copper. All right? And then, so copper ion gun. No more. And then competition between a sulfate and hydroxide. You never ever write an equation for sulfate or carbonate or nitrate. We ignore this particle for a few seconds. They never form a material. Clear? We ignore presence of this material, either sulfate or nitrate or carbonate. We will see nitrate in a few seconds. But it remains in the container. Negative and the positive attract each other. Of course, we have a lot from this one. Okay? So we get sulfuric acid. You get important question only. I'm talking again about the product. We get copper metal, reddish brown deposit at cathode area. We get this color, reddish brown or brown. We get colorless oxygen gas at anode. And we get sulfuric acid. Okay? You get two important questions. You may get it in your final exam. It is what? Anyone remember color of copper sulfate solution? Blue, excellent. Which material, which ion gives the color? A transition metal ion. A copper ion, it make a copper sulfate when we study the periodic table, inshallah, or testing, Analytical, we understand this material, it's blue. You may see in the lab, it is either blue solution or blue crystal. Very famous. We have also a flame test. When you burn a copper sword, you get blue flame. So very famous, blue color. Okay. They will tell you one from two questions, same question but two different ways. الcolor, why الcolor change from blue to colorless? Why الcolor change from blue to colorless? Or why color fades out? No. Copper ion is removed. Where it is removed? It is gone, forming copper metal. That is, the particle makes the solution blue. I repeat this question again. Well, the student online, they will ask you why a color start to be colorless or fades out. What's the meaning fades out? Becomes paler. And instead of this royal blue or dark blue, you will get very pale color. Very pale. I don't have even pale blue, like maybe similar to this one. Pale. All right? Or maybe colorless. A reason for that, because the copper ion already reduced to form copper metal, or already a copper sulfate formed what? Sulfuric acid. The color of any acid you may see in the lab, it's colorless. When they prepared acid for titration, hopefully you go to the lab. Or no? You don't go to the lab? Ask a teacher to go to do titration, to do testing of ions, to do filtration and distillation, chromatography. Ask your teacher to do that. Nicely, Muhammad. Nicely. You ask your teacher nicely. Huh? Well, don't mention Miss Sumaya at all in front of any teacher. Please. All right? So ask nicely, I need to go to the lab. I need to see titration. I tried to study this part of testing, but I'm not good. Be smart when you talk. Okay? So, any acid you see, something called volumetric flask in the lab, it's like water, exactly. Exactly. So we have colorless acid formed. I repeat again this question. El copper sulfate, it is very famous material. In chemistry, it is blue. Even you do crystallization in the lab, you get crystals. It is blue color. But once we remove a copper ion, we will understand that more when we study periodic table. Transition metal compound, it's colorful. El copper is transition metal. So either because the copper ion is removed or because the sulfuric acid formed. You get this question? Sorry. Now, one of them, it is the same. Chemistry or science or IG, maybe one word equal 2 marks. When we revise the testing, if you give just the color of the precipitate, white precipitate, you get 2 marks or 3 marks sometimes. Okay. So what we get? We get copper metal and we get oxygen gas and we get sulfuric acid. Very important. Let's do another material similar. Silver nitrate solution. I need some help here. Anyone to help me? H plus or OH minus. If you understood el copper sulfate, you will do that. I will write down the series to help. Hydrogen ion, well, copper ion, with silver ion. Ask Jumana because she was confused about that. Which particle will go?
Cathode. Silver.
Jumana. Joanna. I have Jumana in another group. H plus, copper plus 2, silver ion. As you go down, easy to form at cathode area. Which particle will go now? Joanna. H plus the particle in the bottom. يلا يا ليلى, we write down the equation together at cathode. H plus, exactly, because we have plus 1 on. So plus 1 electron, we're not writing. The appearance of silver is what? Gray. Gray. Right? Kind of reaction, it is reduction. Now, any nitrate form a product? Never. So always the equation at anode. What we write down? The third time today. 4OH ion minus 4 electron. Equal what? Oxygen gas with 2 water molecule. You see, it is so simple. You get it, Yusuf? We get silver metal and we get oxygen. 1 second, you like. What is the leftover in the circuit here or in the container you add? Let's see. Just second. This gun and this gun. What's this form? Acid also. What kind of acid? لسه بيفكر. هو عايش في الحلم التسعة. What is this material if you add together? What is this one? HNO3. هعلقك من رموش عينيك النهارده. هعلقك اهو. دي عندي فكره. تمسك العينين كده طول الليل. ولا راشكو اللي جاي يخبط فيك. عندي جروب بعدي. هاير لك. What is the name of this material? Quickly. سلمى انت كمان هعلقك من رموش
Nitric
عينيك.
acid.
What's called?
Nitric acid.
Repeat it 10 times now.
Nitric acid.
What you miss? Nitric acid. Thank you, Aman Allah. Nitric acid. This is grade 9 و 8 يا شباب. So we get what? We get silver metal and we get oxygen gas and we get acid, nitric acid. What's your question, guys? Sorry? Ask whatever you want. ما تخافيش انت كده ولا كده في يوم من الايام مش هتروحي. I promise you. ما تخافيش يعني هيحصل حياتي جارتي مفيش مشكله. تقعدي تروحي الساعه 4 الصبح 5 الصبح تاني يوم تقعدي تذاكري بس كيمستري كده يعني. امتحان ورا امتحان ورا امتحان. اختاري البانشمنت اللي انت. قولي your question, don't be shy.
Question.
طفي معاكي. Okay. I repeat again this part, please pay attention. We talked about this electrochemistry series again. We talked about this electrochemistry series. So, any salt above the hydrogen, like a sodium chloride, when solution HOH will never get metal. I repeat again, will never get a metal from solution above the hydrogen. Right? We never get metal. What we get? Because the hydrogen always in the bottom of either ion here. We said as you go down, easy to discharge. The meaning of easy to discharge, it loses its charge. Right? So we get hydrogen gas, we get chlorine gas, and we get sodium hydroxide. Alright? And we did 2 examples. Never mind now L dilute. If you have an under hydrogen solution, yes, we can get metal. If you have copper sulfate solution, so this 4 particle, what we get here, the copper in the bottom, always it will go. So we get copper metal, reddish brown, a sulfate never form a product, and we get oxygen gas, all right, and then sulfuric acid remain in the container. So we can get important product here from copper sulfate solution. In fact, it's important in our life. All right? When we talked about the silver nitrate, always check where is the location of the ion. We said the sulfate or nitrate never go. I have H or OH. Where is silver ion? In the bottom. So this is the winner always. If there is other ion with it. So we get silver metal, gray metal at cathode, and we get oxygen gas at anode, and we get HNO3, nitric acid. Another question regarding that. Why a pH value decreases why the pH value decreases. يلا حبيبي. What is the pH value for any salt? The pH value for any salt, it's what? Neutral. How much it value? Excellent, 7. The pH value for a strong acid, I get sulfuric acid or nitric acid?
Below 4.
1 or 2 or 3 maximum. I didn't revise that yet, but you will get this question. They will ask you why the pH value decreases. We know any salt, it is neutral salt. What's the pH value for neutral? It is 7. We will study that later on in the chapter of acid and base. Maybe you get the question in electrolysis. Not necessary to put a question in order of the syllabus. Question about the testing, question about the redox, question about an acid base. All right? So we get lower pH value because we get nitric acid. Nitric acid or sulfuric acid is strong. The pH value for a strong acid, 1 to 3. All right? So compare 7 with 1. All right? Because the acid formed, the material remain in the container, it is more acidic now. All right? So this another question we may see together in any question in our electrolysis chapter. All right. So done with the electrolysis, you get a lot of example here in the note, but we have last part about electrolysis, something called voltaic cell. What is this voltaic cell? Voltaic cell or galvanic cell. In fact, we teach that in American system only, in 3-4 chapters, and there is calculation. For you, it is just a very small part. It is the last 2 or 3 pages of the chapter, all right? Of course, we will go through the chapter together after I finish this part. So, we didn't talk about electroplating, no problem. We will do that also. So this is a voltaic cell. You don't need to read to study all of that, but just read it to understand. Voltaic cell or galvanic cell or just cell, it is a source of energy. I just compare between electrolysis and the voltaic cell, all right? It is the last part of electrolysis, but we have another 2 uses I didn't explain yet. So I'm talking about a cell or a voltaic cell with electrolysis. I need to compare between electrolysis and the voltaic cell. I draw simple drawing in front of you. What is this called? What is this called?
Electrolysis.
Cell. Very good. So this cell or battery for the moment. All right? It is cell or battery.
Okay.
In galvanic cell, I will start to draw this one. It is voltmeter. What does a voltmeter do? It measures a voltage. Of course, you studied that in physics. Well, I will connect also using wire with 2 electrodes. All right? Well, here I connect with 2 electrodes as we know. All right? And a container, whatever it contains. I have here electrolyte, whatever electrolyte, but in this case, I will write down something different. I will write down magnesium and the copper. So it is the first time to talk about 2 different metals. 2 different metals in the voltaic cell or galvanic cell. Let's compare now. I have here a cathode with anode. So first diagram, which is the electrolysis, we have battery, right? We have battery. In this diagram, no battery or there is voltmeter, okay? Easy point. What's the question you missed? What is the difference between electrolysis and voltaic cell or a cell? All right? Next point. Next point here. The definition of electrolysis is what? Breaking down of ionic compound using electrical energy. It is endo or exo?
Endo.
Endo, very good. So it is endothermic process because energy needed, electrical energy from the battery is needed to break down the compound. But here I have a reaction. Our electrolyte always in the sulfuric acid. most of the time. So there is chemical reaction
Mhm.
between this acid and the most reactive metal. We talked about the reactive series. Well, this reaction produces electrical energy. What kind of reaction that gives out energy? Exothermic. Thank you, Layla. So this reaction, it is exothermic reaction. Let's repeat again. الفولتيك cell comparing للإلكتروليس. We have another third point, but I will say it at the end. We have battery. We understand this dry cell is battery. In the voltaic cell, we have voltmeter. This is why it's called voltaic. It's coming from voltmeter. Voltaic cell. Volt. All right? You remember it from its name. So we have voltmeter instead of a battery. And then this endo, because we said breaking down ionic compound by electrical energy, need energy. So this process needs energy. Well, sometimes you see this sign of heating, that we supply energy. What's the meaning of supplying energy? Endo. But here we have a chemical reaction for the moment. I will write down the equation until I revise an acid base. If I have metal, for example, one more reactive than the other, and magnesium on the top of the reactive series, we said group number 1, group number 2, group number 3, and so on. Well, copper in the bottom of the reactive series, and magnesium here on the top. I'm talking about metal, not iron. So this one is most reactive, while copper is least reactive. If you put the most reactive with the acid, it will react first. All right? So let's see this equation. For example, and magnesium react with the sulfuric acid. We will revise that later on. Don't worry. We get salt, magnesium sulfate, and hydrogen gas. This reaction, it is exothermic reaction. We get energy, electrical energy is produced. So we see here value for the voltage. All right? So we use as a source of energy. We use this process as a source of energy. All right? I repeat again. The electrolysis, it is endo because a cell or a battery is used as a source to break an ionic compound. Here we have a chemical reaction produces electrical energy in this case. Electrical energy, it's one kind of energy. So we compare now a kind, it is exothermic reaction. All right? Now, the direction of the current in the electrolysis, I said that last time, but let's remember together. The direction of the current, assume I have sodium ion, very good, yes, chloride ion. Chloride ion will go toward the anode. It loses its charge. The electron will move. If they ask a drone, you draw one arm going from an anode to the cathode end. They will ask, drawing the direction of electron. In negative ion, let's remember the equation when we do this electrolysis. Cl minus E. Where is this electron will go? In the electrode, graphite, or in inert metal. So this one, it will go toward the anode. Well, electron gun here, not only one electron. We have two chloride ions, so we have two electrons and many electrons. It will move in this direction. We write from anode to cathode. So where exactly direction over here? From the most reactive metal to least reactive one. Which one is most reactive? Magnesium. So direction, it will be from the magnesium toward the top. How I know that? Which one is the most reactive one? That's why we said, we talked about the reactive series in the extraction of metal. Let's remember, I put a potassium, talk about metal, not iron. Sodium, this group number 1, and then magnesium or calcium. Group number 2, aluminium, group number 3, and carbon, group number 4, right? Even if you ignore the carbon as non-metal, and then we have a zinc with iron. We understand that zinc is more reactive. We saw that in the sacrificial protection. All right? And what we have under hydrogen, we have a copper with silver. Even it is not ions, it's just metal. All right? So assume I have this potassium and aluminium as two electrodes here. So in direction of current, it will be from where to where? Potassium to aluminium. From most reactive one to least reactive one. It is two questions in fact. Which one is anode? El most reactive one. El most reactive one. Okay? So this one, you check where exactly its location in the reactive series. There's a question in your exam. All right? I know it's a lot of data about this chapter. We will practice questions, but study please at home. So if you have two electrodes, direction of current, how I know? I check where it is located. I have potassium here, more reactive than aluminium. So it's from potassium to aluminium. If I keep aluminium and I ignore potassium and I put, for example, copper, where's the direction now? From aluminium to copper, thank you. You get it? So always from the most reactive one to least reactive one. Because you can't see any sign here. We understand in electrolysis from anode to cathode. All right? So in the voltage cell, the direction of the current, always from the most reactive one to least reactive. All right? One point, the last point in difference here. We understand that an anode, always in the electrolysis, it is positive sign. An anode in the electrolysis is positive sign. But here we have exception. The most reactive one act as anode, all right? But it is negative sign, all right? It is exception. It is different than electrolysis. We are talking about voltaic cell or galvanic cell. An anode in any equation in electrolysis always positive. But only in voltaic cell, the most reactive one act as anode, it has negative sign. So where is the positive? In the least reactive one. Right? So most reactive one, again, I wrote everything for you in the note. Alright, let's see. Here, that's a part you may see question about it in your exam. A difference between a voltaic cell and the electrolysis. I wrote it here. Alright? Electrolysis, there is battery, here no battery. Reaction endo, and this one exo. El cathode has a negative sign, el anode has a negative sign. Hopefully you get that. You have another frequent question regarding this part. I need to compare the value of the voltage. How to find the value, how to increase the voltage, because it's energy. If you will use a same metal, the voltage what? Zero. Zero. I need to increase the voltage. If you put, for example, potassium with silver, it is the last element in the reactivity series. If you increase the difference in reactivity, you get the highest voltage. All right, let's see this case. Here I have copper with zinc. Is zinc somewhere here? Zinc with this copper. You see this distance? Now, the voltage is about 1 point something. Now, if I change here copper with magnesium, where is magnesium? It is on the top of reactive series. Well, copper over here. You see distance? I will give you summary of this point. So you increase, if you increase the distance between the reactivity of the two metals, the voltage will increase. If it is the same metal, the voltage zero. You get this point. Again, I repeat that in the board here. So I have group number 1 always in the top. Assume this potassium.
Okay.
I have here zinc. I have a copper in the bottom. Okay? If you put two electrodes from the potassium, what's the value of the voltage? Zero. Zero. Alright? If I put potassium and zinc, I get certain value. Assume I get 2 volts. All right? If instead of potassium with zinc, I put potassium and the copper,
Q.
maybe we get 5 volts. So potassium and the copper, what I did here, just increase the difference in reactivity. So the best way, well, it is a question in your exam بإذن if they want to ask about this part. How to increase the voltage? By increasing distance, or you choose 2 metals. They will give you, especially in paper 2, write 2 different metals, or even they will give you in paper 4 question to choose a metal from. So if you increase the distance in reactivity, voltage increase. And we have another point here also. You may increase the concentration of the electrolyte. If you add more concentrated acid here in the electrolyte of the voltaic cell, we get also higher voltage. So either way you can increase the voltage. Everybody, خلاص. off. ندى في الحلم 19 وعمر في الحلم 29 وأدهم he's praying يا ريت المس تقول done. I know chapter it's hard, but we have to finish. معلش. then بس I will explain electroplating and purification, and that's it. It's very easy. So شباب, please study this chapter. We didn't finish yet. Don't pick your stuff. All right? So that is the electrolysis and the voltaic cell. Inshallah, we will confirm this data when we solve exam paper. So, uses of electrolysis, I will do just 10 minutes to talk about electroplating and purification. We didn't finish. I said I did. Still 15 minutes. Anna, what's your problem? I finished the chapter, please, because I have to do homework. Okay? So we talked about the extraction of metal. Now electroplate. Electroplating, I said I will explain that in electrolysis. Pay attention, actually. Electroplating, we said to prevent the rust. What's the meaning? I need to prevent this ring, for example, from rust. I didn't. Just quickly. I fix it at cathode area. مش عايزة تروحي انت النهارده يا ندى. I fix it at cathode area. I didn't write an equation. Please pay attention. To prevent the rust for any element, for an iron special, assume this ring is ugly. It looks ugly. Nada wants to give Layla a gift. She has only 10 dirhams. So she bought this ugly ring. It is rusted ring. Looks very bad. She bought the ring with 5 dirham, and then she went to the shop to ask this guy to coat it with silver. It's called the what? Silver plated or gold plated. So we're talking about electroplating. Electroplating. Because she's shy to give this rusted ring to Layla. Alright? So we fix the ring. Here, Yanada, check your work. You fix the ring at cathode area. So you want silver or gold, Layla? Gold plated or silver plated, Layla? Gold. So, anode, it will be gold. Anode, it will be gold. Gold is AU. But usually, ya Layla, we don't have gold in chemistry. We write down silver. It's okay, silver, it's nice. And then I put this too, a rod, which is silver. A silver, it will coat, it will cover my ring. Right? Again, an object to fix it at cathode. Well, metal I need to use in coating as anode. Right? What is the electrolyte? Aqueous solution of silver nitrate or silver sulfate. Aqueous solution. Please don't forget that. Aqueous. Maybe you don't hear me asla. We have, well, I know you are tired. Me, well, I have another class in grade 12 now. I'm tired, but what we do here? What we have to finish. We have one equation and to flip it. Please pay attention. It's important. El anode dissolves. What's the meaning of dissolve? I write down one equation. Silver, one ion, formed we get silver ion and electrons. That's it. So where this ion will go? To the electrolyte. I get silver ion here in the electrolyte. Where it is will be attracted? Toward the cathode. So you flip an equation at cathode area. So one equation and you flip. يبقى this equation at anode area, and then at cathode, what we get? You flip it. Ag plus E, we get silver. We get silver. So this ring, it will be coated with silver. Now it looks better. It looks much better. So Nada will give it to Layla, and it prevents rust. Never rust, because already it is not exposed to either air or water. Electroplating. It is important technique. Last one, yes. Without electroplate. But you have IG, ya Fatma. Okay. Okay. I taught you how to do electroplating to give a gift for your friend if you don't have enough money. The other one, I need to purify a metal. Important question. If you have impure metal like zinc, I fix it at anode. Okay? So assume this impure zinc. Same way exactly, same writing equation. Well, cathode, it will be very thin layer here of pure zinc. Right? Any metal. And then electrolyte, it is aqueous, zinc nitrate or zinc sulfate. Alright? An equation, same equation we wrote here. One equation and you flip it. So always an anode dissolves. Dissolves يعني forming ion. Okay? Remember, anode is positive, so it forms a positive ion. Okay? That's the equation at anode, and then you flip it at cathode. Allah ya Adam. Honestly, when I look at you, عايز امسك البن كده plus 2 electrons will get zinc. Assembly. What will happen here? I get pure zinc at cathode area, just one equation and just you flip it. So the mass of cathode increases and this mass of anode decreases. It is done. I know you didn't hear me. I will send the recording of other group because I forgot to do recording today. The anode always dissolve. What's the meaning of dissolve يا جوانا? It forms ions. Positive, positive. A silver only positive 1. While zinc it is plus 2. We will practice this question inshallah. Change in what? Because this, it contains impurities. On the right hand side, because by loss of it, forming ions. And then you just flip an equation to get pure zinc. Because this is not product. It will go here toward the area, this electrolyte, and then attract. Alright? Hopefully you understood that, ya shabab. Shabab in online, if you have a question you may ask, but I have here hyper student at home. We still have 7 minutes. I think ya Adam, it's better to stay with me ومين تاني. بالعكس, I will help. In what?
والله مصر عندي بيولوجي.
It is science. I can teach you.
البس
I can teach you.
بس جايبه شابتر من جريد 9 حطوا لنا
خليه على الزول. اوكي يلا. الوش. اوكي شباب. منا عمر سيف. Allah, everybody understood everything. You have any question regarding this part? I will send homework today and also recordings of the class, but with other group. Okay, Shabab? Okay, Yemen. Bye. Bye-bye, everyone. Bye. Bye, Yemen.